Our localization method works is we have four line sensors at the bottom, which will read the four inner patterns on the block. Then we combine that with the four ultrasonic sensors, and it makes all the blocks unique. And if you think about it, we have four locations here, and they have two possible states, whether it's black or white. So we have 2 to the 4 combinations for the floor pattern, and then we have also 2 to the 4 combinations for the ultrasonic. So that's 16 times 16, it's 256. So it's a pretty robust way to localize. And if your map gets bigger, simply adding one more ultrasonic sensor at the bottom would make it 2 times more. So it's like an exponential. So I think this localization method not only works in our project, but it could work for a bigger map. And yeah, so we're just gonna go and place it in different spots, and you'll see where it is on the map. So that's the right block, and then we can try another block here, for example. Right. Okay, so here is the map that we used, and it has numbers 1 to 24. So it starts from there, 1, 2, 3, 4.
Wait. You can pointing it again.
Yeah,
Where's
so
1?
1 is the very left one. So this is block 1. Block 1, and then it increases block 2, block 3, block 4, block 5, block 6, and then it starts again, block 7, block 8, block 9. So this localization, it can localize any of these squares. Column 6 shows block 14. That's the third block from the bottom. 1, 2, 3, that's right. You can move it down one more. So it should be block 18 here. Moving it down. So it's localizing. Lights up. Block 18. Block 18, bottom left, that's right. The trickiest ones were 19 and 22 because they're actually the same. But the way I differentiate them is block 19, it's closer to the left wall, or the left wall is only like 1 block away. And block 22, it's the right block is 1 block away. So those were the 2 trickiest ones. So I'll show block 19 now. Placement is pretty important, so I'll reset it here. Lights out, so it should be block 19. I'll check here. It's block 19, that's right. So I'll check a few more, like maybe 15, 10, 13. Placed it down, it's localizing, lights up. So this should be 15 because it's that middle block, and 15 it is, block 15. Let's do 10, 13, test a few others.
Are you going to this spot? Are you going to here?
I'm just localizing, so I'm just doing the personal task. So it's localizing. This should be block 10. It localizes, and it's block 10. I'll do a few more, like 30, maybe 17. Doesn't matter. Anyone. So here. Go here. So let's try 17. So 17. It's localizing. And it lights up blue. It should be good to go. Lights up blue. And this is block 17, and that's right, block 17. You can try block 6. It works for every block, but I'll just try all of them for you. So it's localizing for block 6. It's localized. Block 6, that's right. So let's try 21. Which way are you guys going? Which way? Can I go here? I'm just testing some random. I can test every block and it works, but yeah, because we tested this. So reset, localizing. It's localized. So that's block 13. And block 13 it is. So try every block. 5. Localizing. It's localized for block 5. Block 5 it is. Block 5 it is. What else have we tried? We can try 12. Localized. Block 12, block 12. The code, the way it works is, my initial idea was to scan the 16 by 16 block, but that seemed tricky because there are, it would be hard to scan that. You need 16 line sensors, or you can rotate it, but you'd have to be super precise. So first we started with one line sensor rotating 4 times, and that worked. But we wanted to do something more robust, so that's why we used the 4 line sensors. And the way it works, really the code is, I first tested it on MATLAB to make sure it worked for every block and to check that the blocks were unique. So here you can see on MATLAB, I first put the information in as an array. So the top 2 rows are the colors. So I made the outer color 0, but it's the 4 inner blocks that we're looking at. So it's 2, 1, 2, 1. That's like shows the colors. So white is 2, black is 1, and then the last row is the ultrasonic readings, And so 0, 0 means the top one is closed, so there's a wall on the top. This one means there's a wall on the left. Then this means that there's no wall on the back, and this means there's no wall directly on the right. And so I did that for all the blocks 1 to 24. Then I run this for loop right here. So it's just going through all 24 blocks and checking if your input block is equal to the all blocks. So the input block is the readings from the Arduino and from your robot, and then it returns the block number. That's how I started, with just making sure that my localization idea worked, and then I implemented it in Arduino. It was a bit different because there's no, I don't know if there's arrays in like there are in MATLAB. So the way I did it is I implemented each block as a string. So each string has line readings and the ultrasonic readings there. And again, for the localization, I just run a for loop. So one last thing that I had to improvise on was like the line sensor readings sometimes were faulty because the paper is bumpy, and when the paper was really close to the line sensor, it would always read black. So as you can see here, I added this acrylic thing that's longer than the line sensor to push the paper down, and that gave us reliable readings all the time. And as you saw in our team task, the localization worked perfectly both times, and it worked every time we tried it. So yeah, that's everything.
Non stop. This is awesome.